All right, thanks, Adam. Hello, everyone. I would so let me start by talking about the scope of this webinar and what you're going to hear about. The 2.2 release, which we've been working on for some parts just under a year and some parts over a year, is largely focused on infrastructure changes to support massive improvements in scalability and performance. And so this webinar talks about how to achieve better performance and scalability through 2.2, and I'm going to go through different parts of the product so that you can see what's changed underneath the hood and how you can leverage it. So that's the intent of optimizing performance and scale. What we won't be doing on this webinar is going through a detailed set of best practices for scaling Neo4j. And if that's what you're expecting, I'd encourage you to stay on because I think this 2.2 material is still going to be useful to you. It's an amazing release. We're super excited about it. If you join expecting to hear about 2.2, that's awesome. Can't wait to talk about it. Andreas is going to do a demo of some of the changes in the Neo4j browser, which just looks and feels so much better in so many ways. So lots of good changes to the development experience. We'd welcome your feedback afterwards as to additional topics you'd like to hear about after this. And we of course have some time for Q&A. So without further ado, the themes for the release are performance and scalability. You just heard I say that. And our goal was, as more and more people are using Neo4j and pushing more and more limits, and at the same time, as Cypher has really proven itself to be the most convenient way to develop things, we, number one, went in saying we want to make Cypher faster. How do we do that? Well, lots of different ways we can do that, and we've optimized Cypher in small ways over time. And what we realized was we needed to do some pretty radical things in order to get Cypher closer to the native Java API speed. So there's that, and then on the scalability side, well, if you break down scalability, oftentimes read and write scaling are what come up at the very top. And so from a read scaling perspective, we made lots of improvements to facilitate that, opened up a lot of areas that were previously bottlenecks inside of the internal architecture. And then same with write scaling, a number of other areas that have changed to support that, and I'll get into those. So what changed in Cypher? Well, the biggest thing is we found that the way we were previously optimizing queries, which was to follow the same path and develop a path based just on the question that was being asked without regard to the actual graph that you were looking at and how many nodes and how many labels of the type and how many relationships per label and all these statistics you can potentially consider that might actually impact your execution. What we decided to do was, or discovered was the most impactful thing we could do is to actually, number one, start gathering statistics, which meant we need to figure out what statistics are actually important for execution, and then gather those in a database, and then use those in a smart way in the query optimizer, which actually required creating a new query optimizer that now runs alongside the old one. And what we've found in the course of doing that is that for certain queries already ran well, so they still run well. And certain other queries that ran less optimally, and in some cases very much not optimally, the query performance literally can be, twice as fast, 5 times as fast, 10 times as fast, even 100 times as fast. And here are a few examples. We have hundreds of Cypher queries that run multiple times every day as part of our build process, and that And those are queries that come from, many of them come from the field. And we run these through our test infrastructure to make sure that we are, well, the database is able to perform well in all those common scenarios. So it's sort of a representative set of queries. And by the way, we're always on the lookout for query donations, which actually means a query and a data donation, because we need the graph in order to do that. So if you have something that's not confidential, of course, or that you can scrub to be not confidential, and you want your queries to actually run inside of our test infrastructure, that's a big benefit to the community, and it's a big benefit to you. So here are some examples. These actually come from a music data set. And at the far left, you can see an extreme case. This is a query that ran in 1.8 seconds that still runs in 1.8 seconds with the cost-based optimizer, the rule-based optimizer. That with rule-based, with the cost-based, sorry, now it takes 23 milliseconds. And at the far right, you can see a case where I had a query that already ran, 16 milliseconds is good enough for most things. But if you're running that query 5 million times a day, then maybe having it run in 0.9 milliseconds actually makes a difference. So those are a few examples, and I encourage you to try it out, give us feedback, and of course the kind of feedback that's most actionable for us will include your queries and maybe an explain plan, and then possibly the data if that's something that's appropriate. So we look forward to hearing what your experiences are with this. We've been really happy with the performance so far. And what we've also done is you've got all this magic happening, inside of what's previously been a black box, and it can be a little daunting and sometimes a little frustrating to not have insight into what's happening. And so in the spirit of helping to make sense of data, which is what Neo4j is all about, why not help make sense of the query plans and what the database is actually doing? And we've developed a new visualization to show what the query plan is doing. They're called visual query plans, and you can see an example here of a fairly intricate query. I tweeted last night an even more intricate one as our engineering team in their post 2.2 launch bliss was competing as to who could create the most visually beautiful, which also correlates with most ugly from an execution perspective, query plan. And so you can have fun with this too. But more important than the fun is this actually becomes a useful tool for understanding what Cypher is doing. Max DeMarzi's done a good blog post 2-3 weeks ago showing how he was able to improve the performance of a particular query by using the visual query planner. So we hope this is something you'll use, that you'll find more, that will help Cypher appear more transparent. And again, we'd love your feedback there. And good. So we still have the rule-based optimizer I mentioned, and you can choose whether to use cost and when to use rule. By default, Cypher will do the best job of choosing what it thinks is the best optimizer, and usually it chooses the right one, but not always. And if you want to experiment and try tuning your query, then I'd encourage you to try forcing Cypher to use the rule or cost-based optimizer. And here's how you do that. You just say Cypher rule and then your Cypher statement, Cypher cost, then your Cypher statement. And again, your feedback there would be welcome as well. Here's a query that ran faster in cost, faster in rule, et cetera. Where we actually found just post-GA that there's a whole set of queries that involve arbitrary length queries where we had previous testing had showed that the rule-based optimizer was better, so the default is more conservative and shows rule. And then we re-verified that after releasing 2.2 and found that changes we'd made in other areas actually made cost better across the board for that. So the optimizer, at least in one known area, and this will change with in the next patch release, it actually has misses one opportunity in one set of query patterns for using cost, and so you can force that. That's one of the reasons why we did that. And this is the first thing you can try when query tuning. There are, of course, lots of other things you can do when attempting to tune queries, but just trying, hey, how will this perform with cost? How will this perform with rule? It's the first thing you can try. And then how do you actually run this? Well, you have two ways you can run a visual query plan in the Neo4j browser. And one is to do an explain. That'll show you the plan, but it won't run the query. And the second is a profile, which will first run the query and then show you the plan. So that's what that looks like. Okay, on to read scaling. So this the first set of things I showed pertain only to Cypher, and then everything else I'm going to talk about pertains to all the APIs, native Java API, etc. And what we determined in, and actually let me skip to the next slide and show you a picture. In 2.1, Neo4j has, as those of you who are familiar with the architecture and used to administering Neo4j know, has an object cache, and then the object cache uses memory mapped I/O, so there are memory mapped data files, and which is effectively delegating that lower level of caching to the OS. Well, it turns out in highly concurrent read scenarios where I have hundreds or thousands of read threads all going at once, the operating system was not, we were actually bottlenecking on being able to serve up data from these concurrent read requests and service everything at once through the MMIO layer. And what we decided was, if we really want to scale in this direction, in the read direction, we and get better, more linear scaling as you add cores to a machine, and make better use of modern hardware and make better use of the cores that are there in the first place, then we should actually have Neo4j delegate, rather than delegate to the OS, to have its own page cache. And the term in memory is meant to emphasize the fact that, or point out the fact that this actually gives you all the benefits that you would otherwise get of a quote in-memory database. But what people talk about as being in-memory databases these days don't have any persistence. So you pull the plug, you lose the data. And with Neo4j, you don't have that limitation. So you get kind of the upsides without the downsides. And what this gives us, and I'm going to go back to the last slide. What we did is we created this new page cache. It replaces MMIO. This all happens behind the scenes. There's not much you need to worry about. There's one new config parameter that will allow you to set the size of the page cache, and the default's usually reasonably good. But if you're in production, I'd recommend actually reaching out to us for help tuning that, and over time we'll develop better better recipe books. But until then, well, if you're going to production, we'd love to talk to you anyway, because there are so many things that that impact how you might want to configure and tune your database. But this page cache, it's auto-configured, it's statistically optimized. Bottom line is it's much better for highly concurrent read situations. If I have one read thread this won't matter. But you know, the Cypher query optimization will matter. But this is really about taking the database and making it handle a much higher number of concurrent threads with each instance. And of course, you can still always scale horizontally as well. But so now this is an added feature. All right, let me fast forward past that. So let's talk about right scaling. And I'm going to start with a picture here too. In 2.1 and earlier, so I want to show you what happened before so that you can understand why we changed in 2.2 and what exactly changed. When write requests came in with 2.1, well, what happened? Neo4j's Acid, which we've actually discovered is pretty important for graphs. And what that means is that Neo4j writes to a transaction log before the transaction comes back and says that it's been successful. And that the writes to those transaction log were essentially happening one at a time. So if I had 100 or 1,000 threads, and lots of our users have those kinds of volumes, the database will handle it, but what will happen is internally there's some queuing that happens in transactions were essentially being pushed through one at a time, which limited scalability. This became a bottleneck. And to make matters, more expensive as far as pushing each transaction through, not only is Neo4j Acid with respect to the graph, it's Acid with respect to the index. And the way the index transaction log has been kept in sync with the graph transaction log is through Twophase commit. And Twophase commits are not cheap. So you had serialized commits taking place one at a time, each doing a two-phase commit. And what's happened in 2.2 is two things have changed. First of all, if you can see where in the center you had sort of this bottlenecking point. That no longer happens. What happens is while the writer is off writing to disk, any transactions that come in during that time fill into a buffer. And then that buffer gets flushed down to disk with however many transactions can fit into it, which can be quite a lot. And it varies according to the size of your transaction. So for very small transactions, you'll fit a lot. For very large transactions, you might just still fit one for an extremely large one. And so that's the first benefit. So expect that the smaller your transaction, for medium and small transactions, you'll see a much more extreme gain. And then, and less so for larger ones. But then what we also did is relieve the second bottleneck where you had to do a two-phase commit between two different logs. And the way this was done is to actually create a new transaction log that handles both the graph and the index. So that's relieving the two biggest bottlenecks for write throughput. And we've seen some pretty huge numbers, and we're now working through, probably 10 years from now, performance is all about bottlenecks, right? You just keep finding the biggest one and nailing them down. So we're already looking into what's next. But the impact that this has made and the impact that the new in-memory page cache has made has been absolutely huge. And so I encourage you to try those out. So with that said, that's a bit of background and overview of what's changed in the engine. And I mentioned that there are some really nice Neo4j browser enhancements. I'm going to hand the presentation over to Andreas Kollegger, who is behind all of these enhancements. So he will give you a demo.
Hey, Philip, thank you so
Hey,
much.
Philip, thank you so
Hello,
much,
everyone.
and hello, everyone. Sorry about that bit of echo. I think we're all set. So I'm going to give you a quick run through of Neo4j browser. This is the user interface that's built into Neo4j. When you fire up the server, it makes a small little web app available that you can just connect to. Here I've got Neo4j running on my local host already, and so I just went to port 7474. Actually, and of course it'll do a little redirect, and Neo4j browser loads up. Um, Even though it serves up this little web app, to actually do any data interaction with the database, of course, you've got to authenticate first. So before you do anything, the first step is always to log in and then connect to the database. Now, when you get started, you'll notice that this is sort of a little REPL type environment, if you're familiar with that kind of development mode, where you've got this bar up here where you can enter commands and then things run. Automatically, the first thing that gets run is this little introductory material that provides some quick links for learning about Neo4j if you're just getting started, showing some code examples, and also monitoring the system. If you already have a system that's been up in operation, you can just click right to that. Um, oh, sorry, actually, I'm not entirely sure. Has everyone been seeing my screen? That might have not happened. Yeah, we're all good? Okay, great. So let's go ahead and look at some of the more new things actually are in the code snippets that we've included. If you jump to the writing code section, you've got a couple different options for how to start looking at what it means to write code with a graph database. There is a kind of fun pop cultural data set of actors in movies that we've created this movie graph. You can take a look at that. That's a fun one to look through. If you're coming from a relational background, which many of us are, of course, it might be more helpful to step to this next one instead, which is the classic Northland graph that we've taken and imported into Neo4j and take a look at actually how it would behave differently and also how you would structure it a little bit differently. And this third option is if you just want to quickly generate some queries and generate a graph of yourself, we've got a little template that helps you, write the Cypher queries. Cypher is our graph query language. Let's take a look at this middle option again. We'll look at converting from a relational database. This is like a little mini kind of slide deck that's built into the application. If I go to the second slide here, we see that the first thing it does is it takes you through how you would actually do a data import. Here on the lower left, you see a little illustration of the classic, the table structure that we're importing from. And on the right are the commands, the Cypher commands that actually would import that data and then change it into a graph instead. What we're doing here is we're using a statement called load CSV, which, as you could imagine, loads CSV data. And then as we're loading that CSV data, for each row in the CSV, we're creating a new node. So that's what the parentheses there means. So we're creating a node, and then we're setting some properties on that node. The references here, of course, are all back to each row that's coming in. So on that node, I'm going to set generically all the values to row, and then I'm going to convert some of the values into floats. Continuing along that same idea, once you've got like just some basic data records imported, to turn it into an actual graph, where in the relational world you would have only had foreign key references to relate one record to another, in a graph we have a data relationship. We actually have a data structure that describes how two records are related. Effectively, what you end up doing when you're doing a migration from a relational database is that you import all of the tables directly as they are, and then you look for those foreign key relationships that you want to query across, and you create data relationships out of that. This first query here is doing exactly that. First, I'm matching, so I'm really looking for what we refer to in the graph world as a pattern. It's a pattern of data, and it's actually just two pairs that I'm looking for. I'm looking for products, and I'm looking for categories. So all the P's and all the C's. Find me all the products and all the categories. And then a where clause is essentially calculating the join the way you normally would have done a join in a relational database. But now, here's the graph part of it. We go ahead and calculate this join, but then we materialize it into a data structure so that we can very easily and quickly take advantage of all the graph properties of looking for patterns of things. So based on this join that we've done here, we create a graph pattern. So we're adding this new relationship from the products to the categories that are related through this foreign key relationship there. Something similar happens for the products and suppliers. And then based on that, we can run some of these queries here that show how easy it is to just, let's see, for instance, here we can find all the suppliers who are produce suppliers. The query looks like this. If I click on the text, it shows up in the editor bar up here. I hit the play button, and the query runs. And we can see that Grandma Kelly's, Tokyo Traders, a few other places are produce suppliers. Great. With that, you can continue through this on your own, of course. I encourage you to go ahead and download Neo4j 2.2, and you can work through this example. We then go on, we load all the customer orders, do the same kind of thing. We create some indexes, as you would expect. And when you're done, you end up with a subset of the Northland Graph presented as the Northland relational database presented as a Northland Graph. There's a full set of this actually available on our website. This is a little sample that's here. I stole one query from the website to show you some other fun things. Now that we have Northland Graph loaded up, I could, for instance, find all the customers who had ordered produce by running this query. This query, if we look at the query itself, creates a pattern that says, let me find all the customers who purchased some order where their order was for a product, where the product is in the category produce. Hence, all the customers who ordered produce at some point. Having run that query, I get back a small graph, and I've limited it to just 10 results. And the 10 results ended up being this here, where in the way that it's come back, the long life tofu appears to be the product of choice. You can see that all these people ordered that. Here's the orders themselves. Let's take a closer look at, I don't know, somebody here. Who's this? What a great name. So you can see if you double click on this person here, we can start to, now that we have some data from the graph, we can double click and start to explore data around that. So this person here, Warshin Herku, has a bunch of other orders in addition to having ordered tofu. In this one order for tofu, you can wonder, well, what else did they order on that? If you double click that, you can see that in that same order for the tofu, they also had some gnocchi that they ordered and some tourtière, which is a product with which I'm not familiar. But you can see that it's pretty easy to just sort of explore and understand the data that's in the graph. What's fun about this visualization is that as you get to know the data that's there by just kind of exploring it, you will visually start to notice patterns, and the patterns that you're noticing are exactly what you would end up using later for writing queries to then build an application to actually do stuff with the graph data. So there's a great sort of round trip that happens when you create a bunch of graph data, you visualize the graph data, and you understand new things that you can offer to your customers or to yourself, new insights, based on just visualizing the patterns and then taking those patterns and turning them into graph queries. Okay, let's move on from that. Oops. And one other thing I wanted to show you is, so that was the graph visualization. Philip had previewed a little bit of the query planning that's available. And if we take a look at this query that we just ran, if we want to see the query plan for that, we would just say profile in front of it, run it again. And now, as part of the result, we still have the graph data, we still have the rows returned, but there's additionally a new plan tab here that's available. Now, this plan is not as complex as the fairly elaborate one that Philip had previewed, because it's a very direct query to actually solve for us. But just as Philip had showed, you can actually dive into any part here and take a look and see what this step of the plan is doing and what the cost of that step was. This is a really easy way when you do have a very slow query to try to identify what the small parts of the query or what the difficult parts of the query were that were taking all the time. Often you can sort of just revise your query. You might realize that you were exploring more of the graph than you thought you were. You were doing some Cartesian product when all you want to do is just find the third relationship away from a friend or something. And this will help you identify some of those either errors in what you've asked for or ways that you can actually ask for something a little bit more efficiently. Now, when you're getting to start looking at these query plans, you're looking at your own queries, there's always a help system that's available. And if you're not sure how to understand the things that's there, there's actually a help topic about this as well. It's the help query plan. And this is basically, again, a mini sort of slide deck similar to what Philip had been showing you. But here you get all the detail about, like, how to understand these profiles and what they do. If you go through, you'll see, what's expanded, that this is the operator. There's some inputs and outputs, obviously. And I think actually that's probably the last thing I want to show you. I don't want to take up too much more time today. I'll be happy to answer any questions that come up later on once Philip is done. But I think we can continue with some more things about what's new in Neo4j 2.2.
Yeah, so that actually covers it. I think we're on to Q&A, and hopefully you've thought of a bunch of good questions to ask. We will monitor the question window here. And otherwise, you got a little bit of time back in your day to, which I would encourage you to use to go out and download 2.2 and check it out. Well, one thing we did add in 2.2 is when you first start it, two things. First of all, you'll be prompted for to authenticate with the database. So there's rather than having authentication as a separate plugin as we've had in the past, that's now built into the database, and you'll be prompted to change your password the first time you log in. So be aware of that. You'll notice that, and that's especially important if you are using Neo4j server with a production app, because now the applications that call Neo4j will need to authenticate. So so make sure you test that, because that'll show up right away. So don't just slip it into production without making sure the auth piece is properly set up. And the other thing you'll see is we now have an option to participate in a customer experience feedback program where you will be able to provide feedback, and using the kind of the left pane info screen, there's an open-ended feedback button. And then also there's an option similar to what Microsoft's done with their program, where they just gather statistics about general usage. There's that as well, and so that's a way for you to actually help contribute back to the community. There's no data, there are no queries sent. It's all just purely statistics on usage to help the product improve. So that.
Great. Well, thank you both, Andreas and Philip, for a fantastic presentation. We do have a lot of questions, so we'll try to go through as many as we can.